Let's take a look at the next question. Now, here we have wavefronts in a water tank uh, entering from a faster region to a slower region. Now, when they enter from a faster region to a slower region, we need to understand that frequency does not change, but speed does change as indicated. Since V equals F lambda and F is a constant, speed is directly proportional to wavelength, which means if the speed becomes lower, the speed wavelength also becomes lower. Now take measurements of the scale diagram and determine the wavelength. Wavelength is defined as the distance between two successive wavefronts. So here we measure this as the distance between two successive wavefronts, also known as the wavelength. We get it to be approximately 2.6 or 2.7 millimeter, or we can also approximate it to 0.2 centimeter. 0.26 centimeter to be specific. The speed of a wave in the faster region is 0.39 meter per second. Calculate the frequency of the wave. We use the same logic here. Now, in the faster region, the wavelength is given, the speed is given, frequency is what we need to find. We can go ahead with the following substitutions. F into the wavelength, which is 0.26 divided by 100 is equal to 0.39. Simplifying, we get the value of frequency to be approximately 15 Hertz. Now, draw lines that indicate the position of the wavefronts of the water wave in the slower region. To indicate the position of the wavefronts in the water wave in the slower region, we just need to show that the wavefronts are bending from faster to slower, or from a region of higher density to a region of lower density. The wavefronts are going to bend towards the normal. The simplest way we can try to denote this is by drawing imaginary lines to help us understand where the wavefronts are going. If this is a particular path a wave takes corresponding to the wavefront, and this is the normal, the wave is now going to bend towards the normal. In other words, the wave is going to bend like this. This is the angle of incidence I. This would be the normal trajectory without any deviation. This is the actual trajectory with deviation, which means the new line is going to be again drawn perpendicular like this, which means the newer lines are going to look like this. Notice we are also drawing smaller wavelength to indicate the fact that the wavelength is decreasing. Now we'll erase the unnecessary lines. Now this is how wavefronts are seen as they move from a region of lower density to a region of higher density, or a faster region to a slower region. State what happens to frequency as it passes to the slower region. As discussed before, frequency is a property of the source and not to the medium. So frequency remains the same, whether it is traveling in the faster region or in the slower region.